Hello students, welcome back to the second video of this playlist. So in this video we will be solving the second question from January 2024 M1, that is Mechanics 1 paper. So let's see what's the question number 2 from this paper is about. Okay, so basically the concepts behind question number 2, it's from momentum chapter that has been discussed in chapter number 6 of your M1, that is Mechanics 1 textbook. So in order to be able to solve this question, definitely you have solved sufficient questions from chapter number 6 of your textbook, that is momentum and impulse. So let's get started with question number 2. So right at first you can see a figure 2 is given. There are two particles A and B. So they are moving in opposite directions on a smooth horizontal surface. A smooth horizontal surface means what? There is no friction, right? Okay. Particle A has mass 5 kg. The mass is given for particle A, and particle B has mass x kg. So we don't know the mass of particle B. Okay, so the particles collide directly. They are having a head-to-head collision. Immediately before the collision, the speed of A is 3 meters per second. That is the U1, basically the initial speed for particle, the first particle. Okay, and the speed of B is given as what? X meter per second. This is basically what? U2. Okay, and immediately after the collision, the speed of A is 1 meter per second, that is V1, since we considered 1 as particle A, and its direction of motion is unchanged. The direction of motion is remaining unchanged. Okay, immediately after the collision, the speed of B is 1.5 meter per second. Okay, so they didn't mention whether the speed of B, like they didn't specify the direction of particle B after the collision, like in which direction it will be moving after the collision. Okay, so that's the introduction to this question. Okay, so part A asks to find the value of x. We need to find out the value of what? X. So x is what? X is basically the mass of particle B. Okay, so the mass of particle A is known, the speed of particle B after the collision is known, okay, and speed of A is also known. So what we need to do, you need to have an idea about the conservation of what? Linear momentum, right? So for part A, we will be applying the conservation of what? Linear momentum. So we will be using what? Conservation of linear momentum. We will take this direction as positive. Okay, this direction, right to the right, it's positive. So if you consider to the right is positive, so what would be the case? Initial speed of particle A is 3, so 3 times 5, right? m1u1 plus m2u2, right, equals to m1v1 plus m2v2, right? Okay, so that would be negative because it is coming from the opposite, right? So that would be what? X times before the collision, the speed of B is x, so that means it would be x squared. This is equals to what? After the collision, m1v1 is what? 1.5, or this is the particle. Okay, this is v2. Okay, m1, this is v2, and the top one is basically what? v1. This is v1. Okay, so m1 v1, that means 1 meter per second. That's the speed after the collision. The direction is unchanged, so that would remain positive, right? Because we took the right direction as positive. Okay, so what we can say, m1 v1, so that is 5 times 1, that is just 5, and After the collision, the speed of B is 1.5 meter per second. Now the question is, since they didn't specify the direction of motion of B after the collision, so what you can say, in which direction it will be moving? Just use your common sense to understand. If particle A keeps moving to the right after the collision, that means B should move to the right direction, right? Because if B keeps moving in the left direction, then that means B has gone through particle A. It doesn't make sense, right? So that means the direction of particle B has been what? Reversed. So that would become also what? Since it is towards the right direction now, particle B, so that would be positive. So there is 1 point, what's the mass? Okay, 1.5 times x. M2 is x, and after the collision the speed of B is 1.5 meter per second. Now you just need to calculate the values. So take x squared to the right side, so x squared plus 1.5x, 3 times 5, that is 15. So if you take it to the right side, it will become negative 15. So negative 15 plus 5, that is negative 10 equals to what? 0. So basically 1.5 is 3 over 2. So multiply both sides by 2. You will get twice of x squared plus 3x minus 20 equals to what? 0. Okay. So what we need to do? 2 times 20, that is what? 40. Right. So can we use some formula? 5 times 8, that is what? 40. So twice of x squared plus 8x minus what? 5x minus 20 equals to what? 0. Right. So take twice of x common. So you'll get x plus 4 minus 5 there, x plus 4. This is what? Middle term factorization. Fine. So either the value of x is 5 over 2 or the value of x is negative 4. So which one is the correct value? Definitely, since x is the mass can never be negative. So x is equals to what? 5 over 2. That's the value for x, and that's what they have asked in part A. We got it. Okay. Next is part B. For part B, they are asking to find the magnitude of the impulse exerted on A by B in the collision. Okay. Let's consider impulse exerted on A. So on A, we know that impulse is what? Force times the time, right? So also impulse is known as the change in momentum. So this change in momentum, impulse exerted on A. So for this exertion of the moment of the force of the impulse, for the exertion of impulse on A, like whose momentum will be changing? Definitely particle A's momentum will be changing, right? So who is applying the force? Basically particle B is applying the force. Okay, so if you consider particle B is applying the force on A, so in which direction particle B will exert the force? Definitely in the negative direction, right? That means impulse is exerted on particle A in the negative direction. That means change in momentum will be also negative. Okay, so impulse is what? Change in momentum, right? I is equals to what? mv minus mu, right? Consider the direction because impulse is a vector quantity. Okay, so for part B, what we need to do is that we need to consider our direction. Okay, we took this direction as positive, so keep it as it is positive. Now consider the impulse. Consider the impulse on what? A or B? Impulse on A. Okay, impulse on A. So mass of A will have to be considered. So mass of A is 5 times. Now consider V. Final velocity. After the collision, what's the velocity of particle A? This is 1 meter per second towards the positive direction. So 1. So V is what? 1. And before the collision, what was the velocity of particle A? That was 3 meter per second, right? It's in the positive direction. So V minus U. So V is 1, U is 3. Okay, so you will get impulse on A, that is basically 5 times negative 2. That would give you what? impulse on A is negative 10 Newton second. So this is basically the vector, like the sign. Since we got negative sign, it means what? The vector. But they asked for the only magnitude. Okay, so what we need to say? So impulse on A by B is what? Is 10 Newton second. If you write till this, you will not get the full mark, because they asked for the magnitude, not the direction. So you need to write the impulse on A by B is what? 10 Newton second. The unit is must. Don't forget to write the unit. Okay, so that was all about question number 2 from January 2024 M1 paper.